Hello students. Today we'll start a new chapter, that is a chapter number 12, that is organic chemistry, some basic principles and techniques. In this video we are going to discuss the introduction part of organic chemistry. Organic chemistry is a branch of chemistry which deals with the carbon containing compounds. The compounds which have carbon, such type of compounds are called as organic compound. So in this we'll be discussing more about organic compounds which have very important role. The organic chemistry plays a very important role because the organic compounds are vital for sustaining the life on the earth. It include the complex molecules like genetic information bearing deoxyribonucleic acid, that is DNA, carbohydrates, and the proteins that are the essential compound of our blood, muscles and skins. Organic chemicals appear in the materials like clothing, fuels, polymers, dyes, and in the medicinal field it plays a very important role. So these compounds have an application in the medical field, in the dyes, fuel, clothing, and even the bodybuilding food, that is protein, is actually an organic compound. The genetic information which is passed by DNA and the important food, that is carbohydrate, all these are actually organic compounds. So let us discuss more about the organic chemistry which is based on the compound made up of carbon. The carbon have some important property, as we have learned in the previous chapter. It makes that a suitable element to forming a compound, an organic compound. That is tetravalency, that is carbon is tetravalent. That means it can form 4 bond with that is a covalent bond with the others. It is very important, tetravalency of carbon. Next, catenation power. The catenation power we have already learned, that is a tendency of the carbon to link in chain in the cyclic form or even in the branched form. The tetravalency and the catenation power we have already discussed, and one more property it makes suitable for making the organic compound, that is having multiple bond formation capacity. That is, it can form p-pi multiple bond with itself and with its other members. So first of all, it is very important to note that in the organic compounds the carbon should be tetravalent. It should be tetravalent means just count the number of bonds surrounding to the carbon here. How much of number of bonds are there? Because of 4 valence electron, it can form 4 covalent bond. So let us take one example of one organic compound. This is one of the organic compound. Let us check whether the carbon is tetravalent or not. That is very most important point in a organic compound, that is carbon should be tetravalent. So let us take about this carbon. Now let us check whether this carbon is tetravalent or not. So let us count the number of bonds surrounding to this carbon. So first I will be counting here. This is 1, 2, 3, 4. When we take the other carbon atom here, let us take the carbon this. So let us count the number of bonds surrounding to this. That is, here one bond is there, 1, then 2, 3, 4. 4 bonds are there. That is, this carbon is tetravalent. That means it forms a 4 covalent bond. Next we'll take the next carbon. Here one more carbon is there, just this one. Count the number of bonds surrounding to this. That means how many bonds are there for this carbon. That is 1 here, 2, 3, 4. So total 4 carbon, it is connected to 4 bonds. That means it is tetravalent. So it is very important to note that whenever you are making an organic compound in which you have to check whether the carbon is tetravalent or not. So if the valency it should be get satisfied here, it should be tetravalent. That is important here. Next one is that it can form pi multiple bond, and we have already learned in hybridization, that is when there is a single bond, that is we can say that that carbon is sp3 hybridized. That means here these two carbon atom both are sp3 hybridized carbon. But the case of second case, in this case, here double bond is present between the two carbon atom, then this carbon is sp2 hybridized, this is also sp2. So whenever the carbon is double bonded, that means that carbon must be sp2 hybridized. What about the third case? In this case, this carbon atom is bonded by triple bond. That means this carbon is sp hybridized. So it is very important to note when the carbon is singly bonded, that means it is sp3 hybridized carbon. When it is double bonded, then it is sp2, and if it is triply bonded, then means the carbon is sp hybridized. And even though when we talk about the bonds here a single bond is there, it shows that there is a sigma bond, and if there is a double bond means from double bond one of the bond is sigma, the other one is pi, and if there is a triple bond, that means one bond is sigma, the other two bonds are pi. It is very important to note, if there is a triple bond, that means one bond is sigma, the other two are pi. When there is a double bond, it shows that one bond is sigma, the other one is pi, and if it is a single bond, that means that bond is a sigma bond. It is very important because the questions you will be getting on the basis of this. Let us take one question here. Let us take the same compound, that is an organic compound here. In this we need to find out which one is a sigma bond and which one is a pi bond here. So first let us make a triple bond here, it is given here. So from the triple bond we have learned that two bonds are pi bond. So I have changed the color. The two bond that is pi bond, that is from the triple bond two bond is pi, and one more bond is there, that is actually a sigma bond. That means this bond is a sigma bond, that is this is a sigma bond and other two are the pi bonds. So all the single bonds are sigma bond. So let us count the number of sigma and pi bond present in this. So let us count here. This is a single bond, that means it is a sigma bond. What about this bond? This bond is also a sigma bond. This one is also sigma. This is also sigma. Here from triple bond, one bond is sigma, and this is also single sigma bond. So just count it, how many single bonds are there? All are sigma. That is 1, 2, 3, 4, 5, 6. So total 6 sigma bonds are there. And what about the pi bonds, which I mentioned here with red color bond? That is 2 pi bond. So we can write here, it have a 6 sigma bond and 2 pi bond. Let us do one more problem here. It is also an organic compound. How you find out the number of sigma bond? That is count the number of single bonds. All the single bonds are sigma. So let us, I am counting here. This one is sigma 1. Here it is there 2, 3, 4. From double 1 is sigma. Therefore 5, 6, 7, 8, 9 and 10. So total 10 sigma bonds are there. All the single bonds are sigma, and from double 1 is sigma, 1 is pi, and from triple 1 is sigma, the other two are pi. So when you count the number of pi bonds in this, number of pi bonds, how we can calculate here? From triple bond there are 2 pi bond. That means here 2 pi bonds are there and here 1 pi bond is there. So total 3 pi bonds are there. So the problems will be getting on the basis of this. you need to find out the sigma bonds and pi bond when an organic compound is given to you. That is, it is given in the problem, that is a text solved problem 12.1. How many sigma and pi bonds are present in each of the following molecule? So here the two molecules are given. We have to find out the number of sigma bond and pi bond present in this. So here better you can expand this one and you write it. How you expand this one? Because here one carbon, first carbon, so better you write here like one carbon, and here one hydrogen is attached. Next triple bond, make the triple bond. Next carbon, this I am writing this carbon, and next is CH. CH means next is the carbon, so make a bond between the carbons, and CH means one hydrogen is there, just write it top of it, then double bond. Then what we have CH, C, one H is here. Next what we have here, CH3. So CH3, better here space is not there, so better I will write down. So this connected to this carbon, and here 3 hydrogens are there, you need to write in this way. Now when you write this in the expanded form, now you can count the number of sigma and pi bond very easily. Just remember all the single bonds are sigma. Double bond means one is sigma, one is pi, and from triple bond one is sigma, the other two are pi. So when you find it out, you will be getting the answer as it is given here. In the next problem here, this also we can expand it. So how we expand this one? Here single carbon, so I am writing this carbon here C, and 2 hydrogen is there with this, so better I will write the 2 hydrogen, 1 hydrogen here and 1 hydrogen here. Next double bond is there, and next is the carbon, so make the double bond. Next is the carbon, and you can see here with this carbon there is no hydrogen, so I'm not writing any hydrogen here. Next is double bond, so write the double bond. Next is CH, CH means C here, and H, better write the H in this way, down or top of it. So here H. Next what is there? CH3. CH3 means what will be the bond between these two carbon? That is single, because single bonds are not usually represented in this way. So that is understood that there is a single bond. Usually double and triple bonds are only representing in this form. That is a condensed formula. Next is CH3. CH3 means C here, and 3 hydrogen. That 3 hydrogen means 1 is here, 2 is here, 3 is here. So this is the right formula for writing in the expanded way for this one. And now you can find out the number of sigma and pi bond which is present in this. So you will be getting the answer in this way. This problem is what is the type of hybridization of each carbon in the following compounds. So we need to find out the hybridization of the carbon. So first of all you have to expand these. How we expand this one? First one, it is very simple, CH3Cl. That means here it is C. CH3 means 3 hydrogen bonded to this carbon and 1 Cl. So this is the expanded form of this one, and here you can see that all the bondings are single, therefore that means this carbon is sp3 hybridized. Now let us look at the second one. Second one is actually a ketone, that we will be getting idea more when we discuss the further one. So how we expand this one? CH3 twice. CH3 twice means how we expand this one? That is CH3. CH3 means 1H here, 1H here, 1H here. Next is carbon, and CO means C double bond O. That is very important. Ketonic group CO means C double bond O. Next one more carbon, because CH3 2 times is there. So CH3, and here we can say carbon with 3 hydrogen. So I will rub this one. So carbon with 3 hydrogen here. So when you find it out here, in all these cases there is 3 carbon here in this, that is the first carbon here. I am talking about this carbon. This carbon is bonded to all the bonds are single, therefore it is sp3. This carbon is also sp3. But what about this carbon? This carbon is sp2 because here double bond, this carbon is bonded to double bond, that means this carbon is sp2. So in this molecule we can say that there are sp3 carbon, there are 2 sp3 carbon and 1 sp2 carbon. Next is CH3CN. It is very important. CN means C triple bond N. CN group, cyanide group means C triple bond N. And one CH3 is there, C, and CH3 means all the bond with hydrogen and carbon are single. So here 2 carbon is there, that is this carbon is sp3 because it is bonded to all single bond, but this carbon is sp because it is bonded to triple bond. So that is the 2 carbon. From here one is sp3, the other one is sp. Similarly you can do this one also. How we expand this one? That is CO. I told you CO means C double bond O. It is N. H2 means I can expand this in this way, and this is one hydrogen. So this is the right way of writing this. So when you look at here, only one carbon is there, and that carbon is double bonded, therefore it is sp2 hybridized carbon. Next, in this also we can check here 1 2 3 4 carbon atoms are there from this CH3. CH3 means here this should be always sp3. It should be sp3. Next, this carbon is bonded to double bond, therefore this is sp2, and this is also bonded to double bond, therefore it is sp2. Look at here, it is bonded to double bond, therefore it is sp2. And this carbon, cyanide group carbon, as I told you, cyanide means a triple bond, that means that is sp hybridization. So when I talk about once again this molecule, this carbon is sp3 hybridized, this carbon is sp2, this is sp2, and the carbon with cyanide group, that is sp hybridized. So in this way you'll be getting questions. Some of the molecules will be given. You need to find out the hybridization in each cases. The similar question is also the problem number 12.3. Write the state of hybridization of carbon in the following compounds and shape of each of the molecule. So as we have learnt, when there is a sp2 hybridization, what will be the geometry? That is trigonal planar. When we have learned the hybridization, there we have learnt the concept then, that is when there is a sp3 hybridization, the geometry is tetrahedral. When the hybridization is sp2, the geometry is trigonal, and when the hybridization is sp, the geometry is linear. So on the basis of this only we have to answer this one. Here this carbon, there is a double bond. Double bond means this carbon must be sp2 hybridized. So when there is a sp2 hybridization, the geometry will be trigonal planar. Next one, look at here, CH3F. It is sp3 hybridized because CH3, I told you whenever there is CH3, that will be sp3 hybridized. So when there is a sp3 hybridization, the geometry will be tetrahedral. And here there is a triple bond, CN. CN is a triple bond. As I told you, CN triple bonded. That means this carbon is sp hybridized. And when there is a sp hybridized, the geometry will be linear. So hybridization we have already learned, and geometry also. So on the basis of this only we can identify the geometry on the basis of hybridization. So these 3 questions are very most important, and you'll be getting any of the organic compound in this way, and you need to find out the sigma bond and pi bond present in it. And even you can be able to get question on the basis of identifying the hybridization of each carbon and also the geometry. So this is a introduction part of organic chemistry. The details will be discussing in the next video. So this is all about this video. Have a nice day.